Hello again, everyone. This is me, Aswan Hilmi, Success Partner with OBA Energy, and I will be your moderator in today's webinar. Just before starting, I would like to make sure that my voice is clear and that you see my screen. So if someone would like to share in the chat area, you can type one for confirming this. Okay, thank you, Adil, for this. I also want to let you know that this webinar is recorded on YouTube. It's live now on YouTube as well. So you can also follow us on YouTube for this session in later times. So this is a typical presentation. Today's webinar titled Build Your Own PVT Calculator Application with Engineer Allen. I'd like to give you 5 minutes short presentation about introducing OBA Energy to you and giving you a short notice about our upcoming service plans. Here is the dashboard that is representing our activities in the recent years. We started here in Egypt in 2019, and we are a team in different countries here in Egypt and in Lebanon and France. We have a group of experienced instructors, more than 40 instructors. Actually, we conducted different technical studies with awesome clients here in Egypt and outside Egypt as well. We, as we have today, the webinar number 72, we have already conducted more than 73 webinars. All these webinars are free and available on our YouTube channel if you would like to review some of them. We are presenting on social media, on LinkedIn, especially. The lower side of my screen shows that we actually reached a lot of applications worldwide. So regarding our 9th wave of upcoming live courses, we have 4 interesting courses for this quarter. We already started with thermal UR modeling by CMG that started on last Saturday and is continuing till 24th of August. We have an off day today. Actually, also the next 3 courses are well integrity management systems that will start on the 2nd of September and end by the 7th of September. Then applied reservoir geomechanics that will start on the 16th of August of September, sorry, and will end by the 21st of September. The last interesting course is stack pipe prevention that will be start by the end of September and end by the 5th of October. You can notice here that we have a break day during these courses, that is Tuesdays like today. So regarding the price list table for this wave of courses, we already have an interesting discount for early birds for these courses. We already started with thermal URs, so this is not applied for this course, but it's still working for the upcoming 3 courses. We also have a package discount for these 4 courses. Don't worry if you missed the first course; it will be available as recording, and you still can join us in the remaining live days of these courses. So for registering in one or more of these courses or for taking the package discount, you can scan this QR code. Also, I will be sharing the direct link for registering in these courses in the chat area. So now you can see the links in the chat. We also have conducted several interesting courses that are now available as recording. All these courses were in quarter courses like the 3 that I presented earlier. So we have many interesting categories here in reservoir engineering, production technology, rig and rigless operation, open and cased hole logging bundles, as well as miscellaneous bundle, including some courses related to petroleum economics, introduction to data analytics, and also using HISIS software. So all these interesting courses, more than 30 courses, are available as recording for purchases. We also provide discount for purchasing more than one course, and as more as you purchase with us, you will get an interesting discount. This is another way of visualizing these courses and training bundles as well. For the big sale and enjoying your discount, also you can scan this QR code now, and it's also mentioned in the links that are now in the chat area. We also have interesting mentorship programs that you can design on your own, choosing your instructor as well as your learning path. So you don't have to stick to a syllabus of one of these courses. You can design your own course based on your preference. I really encourage you to have a look on our website. Just type obacourses.com on your searching engine, and you will find this interesting website that includes all our services that I presented earlier. This is also the recording of the courses you can find there. Here is some lovely pictures from our internship gallery, showing some pictures of the students that visited Egypt from Lebanon, or taking some courses and enjoying some of the visits in the geological sites of Egypt, as well as visiting some of the interesting service companies working here in Egypt as well. You can be an ambassador with OBA just by enrolling in one of our services that I have mentioned earlier, being an internship, live course, recorded course, and you will find a lot of interesting benefits that we provide to our ambassadors. Rules for this webinar, I have muted all the microphones. Sorry for this, but for getting clear understanding of today's webinar. If you have any question, please put your questions in the chat area, and I will be more than happy to read these questions to our instructor, guest speaker for today's webinar, Engineer Alan. Please use your full name. If you are joining us using a name like Galaxy, iPhone, something like this, or Zoom user, so go please rename yourself, as we will be sending certificates of attendance for today's webinar in 1 week from today. So now, time for introducing our guest speaker for today's webinar, Engineer Alan. Alan is a consulting petroleum reservoir engineer with more than 20 years of international industry experience. He is currently based in Australia. He has his own consulting business. In addition to this, Alan is the founder of Crowdfield, a marketplace that connects oil and gas and energy businesses with a global network. Alan holds a master's degree in petroleum engineering from Imperial College London. He is chartered professional engineer at Engineers Australia, member of the National Professional Engineers Register, and is a registered professional engineer Queensland. He is also a guest lecturer at University of Queensland for the Masters of Petroleum Engineering in association with Heritage University. There is more to tell about Alan, but to save time, over to you, Alan, to start your webinar. Thanks for joining us.
Just shared my screen. You guys let me know if you see the screen.
Yes, I see your screen.
Excellent. All right. Thank you, Esam, for that introduction. Hello, everybody. It's a pleasure for me to be here with all of you. This is the first webinar of what hopefully could become a webinar series on a broad range of topics, depending obviously on your own feedback. So the idea is to get this first session out of the way to kick things off, and let's see what you think of it. So I will not spend much time introducing myself again. Sam already did that, so thank you for that introduction. But let me just very briefly point you to, let me see if you still see, do you see the window that I just brought onto the share screen or not with a LinkedIn profile?
Yes, we see it.
You see the LinkedIn profile, okay. Just to understand whether it's sharing the screen or the window only. So just briefly, let me point you to my LinkedIn profile. The link was shared on the OPA invite. So here you can learn a little bit more about myself and my background, my projects. You can also have a look briefly at my consulting business, Morek. Here you can learn a little bit more about my background and a few courses and resources that I also provide as part of my services. But more interestingly, I want to come back to this at the very end. On my LinkedIn profile, you will see there's a link to crowdfield.net website, and that'll bring you to this website you see here. And as Esam was pointing out, this is a marketplace. It's a venture that I created and launched at the beginning of this year. It's a marketplace to connect oil and gas and energy businesses to a global network of niche talents. And the idea is to provide task-based freelance solutions. So my mission with this project is to help skilled individuals like yourselves to continue to monetize your knowledge as the energy transition unfolds, right? So the idea is for you to bring your expertise to the open market and to create digital products that you can bring to the digital store and sell to the open market, right? So have a look at this website in your own time. You are free, obviously, to join our freelancer directory. You can go here, I'm a freelancer, and join. Therefore, you will appear under the freelancer directory with your profile and skills, and businesses can find you. But other than the freelance directory and the freelance two-sided marketplace service, again, the digital store is what I want to bring to your attention, because this very seminar or webinar that I'm offering today is something that you could do yourselves and bring to the open market for anyone in the world to actually have access and purchase. Now, I have two products that I uploaded. You could actually inspect for free. You can download this. This is a bit of a follow-up on Excel capability that I want to actually run this webinar today on. So let me just get that out of the way and let's go to today's session. Okay, now I do not have a presentation, a PowerPoint slide pack to talk over. Instead, what I want to do today is to show you live, in a live demonstration, how you can leverage Excel and a bit of Visual Basic to build your own applications, right? And I want to use the Z compressibility factor as an example. So as you see on this animated GIF on the screen, we want to create a little app where the user can enter the specific gravity, temperature, and pressure, and this app will calculate the Z factor, right? This is the end product after today's session. This is one we want to arrive at, okay? And we're going to do that using Excel and Visual Basic. So let's kick things off, and let me just open an Excel application. So we're gonna do it from scratch, and it went to my other window. So let me just drag it to the share window. So this is the Excel file that I just created. And the first thing we're gonna do is to save this as, let me just drag this thing over. The first thing we're gonna do is we're going to save this as a macro enable. I'm gonna save it on my desktop for now. And what you need to be doing is save as macro enable workbook. That's the first thing that people sometimes forget, and the macros are not enabled. We're going to be running Visual Basic code, therefore we need to enable macros. So we're gonna save as a macro enable workbook, okay? And we're gonna just call this test, or whatever name you want to give to the app, okay? Now, again, the example that I want to use today is to calculate the Z compressibility factor. So we're going to use the Hall-Yarborough correlation. and I want to bring this Whitson website, which you may be familiar with, and drag it to the screen. So you have this Whitson wiki website. Curtis Whitson is basically the PVT guru. And this amazing website here, you can go to the right-hand side and click on that Hall-Yarborough estimation. And this will tell you exactly the methodology to calculate the Z factor. So as it says at the top, is an iterative approach using the pseudo-reduced properties of the gas. So we're going to take this website to extract all the formulas we need to implement in our Excel file the calculation that we want to do. So let me just put this side by side and let's start building in Excel the calculations that we need. So let me just make some room there. So we have the formulas on the right-hand side as we build the calculations on the left-hand side. Okay. Now we're going to need the specific gravity of the gas. Let me just put here gas specific gravity. Okay. And I'm going to put in yellow cell whatever is going to be a user input. So let's say 0.6, which is a typical gas gravity value. Then we want to enter the pressure and temperature. Okay. And again, I'm going to highlight this in yellow because these are user inputs. And let's say we want to use an example, 5,000 PSI, and temperature, we're going to use 200 degrees Fahrenheit. Okay. Now we're going to start calculating things. Now, the first thing we need to do is to turn the temperature into degrees Rankine, because we need an absolute temperature measure to use in formulas. And as you know, this formula is going to be the temperature plus 459.67 to turn that into degrees Rankine. And we're going to use the blue color to refer to whatever is a formula or a calculation, not a user input. Okay, so the first step we need to do is to calculate the pseudo-critical properties, which are taken from the methodology in Curtis Whitson. So this is from here on, it's just following all the formulas that are indicated in the methodology described here on this website. So we need the critical temperatures. We're going to use here, it says the Saturn correlation is what yields better results. So we want to bring those two formulas to here. So those two are going to be yellow cells because they're going to be calculations and not user entries. And one little neat trick that's I'm not sure that everyone is aware of, that these variables or cells in Excel, you can actually give names to them. So the references in formulas become more intuitive and easy to track. So for example, here, you see that refers to the cell C3. You can just click here and rename that thing. And I'm going to rename it gamma because gamma is the Greek letter used to refer to the specific gravity. Same here, you see on the pressure cell, that is cell C5, but you can see 5 there. You can just click on it and rename this thing. So we're gonna rename it as pressure. Likewise, the temperature, we're going to rename it as temperature. And the one we want to use in formulas is the absolute. So make sure you click on that one, this degrees Rankine. So that's gonna be temperature. Okay, so once we have that, we can actually start typing cells and calling for those references using the names themselves rather than absolute cell coordinates. For example, this one here is going to be like that. Just for the sake of time, I'm pasting from other Excel where I already have the formulas to save time, but you can see the formula there, 756.8 minus 131 gamma. You see on the Curtis Whitson on the Whitson website, that's the formula where I have my pointer. That's the one that I have here on this cell. You can see it uses the gamma value, which refers to the cell where I have the specific gravity. So that's why it's so useful to have the cells named in Excel. So that's going to be the pseudo-critical temperature. Likewise, for the pseudo-critical temperature, we're going to use the formula, which you see on the website, and I'm going to paste it there. You see the formula 169.2 plus 349.5 gamma minus 74 times gamma square. So we use those formulas, and there you go. So what we need to be doing is to keep going down all of these formulas in the Whitson Wiki website to build all the calculations we need to finally arrive at the Z value. Now, for the sake of time, let me just drag this file out which we just created, and let me bring the one that I already created with all the formulas needed, just for the sake of saving time. So I don't want to spend time typing too many things here, but you can see, just continue going down, and all of these are formulas that appear on this methodology described on the website. So pseudo reduced pressure. So where is it? Is at the very top. Pseudo reduced pressure is pressure over pseudo critical pressure, which we just calculated. So that's pressure over PPC. Temperature is temperature over TPC, which are the ones we just calculated before. Then we have this alpha parameter, which is that one there. You see the formula? That formula is exactly the formula you see here, which uses a theta parameter, which is that one there, and theta is 1 over TPR, 1 over TPR. So what I'm showing you here is two things. One is we just follow the methodology described on this website, calculating all the parameters we need using the formulas explained here. And we also are using names to make it easy on us to audit the formulas we have in each cell. This is a neat trick to always be accustomed to using. It's very useful. Okay. So after we define a few defining parameters, we enter into this iteration, which is the process that is described here. So you start by assigning a raw value. That's the methodology that is described here. So you guess the reduced density parameter raw. So you start with a value, okay? And then you calculate these parameters F1, F2, and F3. Again, all I've done for the sake of saving time, I've already put those formulas here. So F1, you see there, F1 is minus alpha times PPR plus rho square, rho 3, so on and so forth. I've done the same for F2, F2 14.76, F3 90.7. You see, these formulas is just these formulas expressed in the Excel worksheet. So after we calculate F1, F2, and F3, we're going to calculate next the derivatives of F1, F2, and F3 using the formulas that are described on the website again. And at the end, we end up with a process in which you need to iterate on the value of this row. That's the methodology. That's how you end up at the right value. This is Newton-Raphson optimization routine. So the way this works is you need to guess row until the calculation of F is 0. Now, in this case, it had already been initialized with a near 0. So let me just change the values just for the sake of the example. Let me just change the pressure to 5,000. Let's leave the temperature at 200, or let's put 250 Fahrenheit just to test things. Now everything changed, so we need to recalculate rho, and rho needs to be calculated by iterating. Now, how do we iterate in Excel? So a new value of rho will trigger all these calculations. And what we need to do is to estimate rho such that that tends to 0. You see that there? So that's the iterative process. Now, to iterate in Excel, we can use the goal seek function. And the goal seek function is under data, what if goal seek. Now you can bring this goal seek, if you use it very frequently, you can bring it to your ribbon and access, have it readily available for you. But for now, let's just use it in this way. So what we want to do is to set cell, and the set cell is going to be the absolute value of F, and we want that to be very small. So let's say let's say that for now. You can go even smaller than that. I'll show you in VBA in a minute. But for now, let's do that. And the cell we're going to change is going to be this one. Okay, so just OK. And this thing is going to start iterating. Okay, already found a value. That was a quick iteration. And the value it found was that one. And with that value, F tends to 0. You see that's very small. That's fine. And now, finally, after doing that calculation, we can come back and we have everything we need for our Z factor. So Z factor is calculated as alpha times pseudo-reduced pressure, PPR, over rho, pseudo-reduced density. Okay, so don't get too overwhelmed with the formulas. All I've done here is to follow the Yarborough methodology described on this Whitson website. So all I've done is created formulas following this to calculate the Z factor. Okay, so this is what you would typically do if you wanted to calculate Z factor using Excel, nothing else, right? Now, this is obviously not very convenient because every time you change any of the parameters, let's say you change the pressure or the temperature or the gas gravity, and you need to go here and reiterate. Now, this is a little bit annoying, right? And especially because you cannot translate this into other workbooks where you may also want to calculate the Z factor. Z factor obviously is a key parameter to derive the expansion factor or the BG factor to compute your in-place volumes. So therefore, it's very useful to have a way to readily calculate Z factor in Excel. Okay, so the next step is we're going to recalculate Z now using Excel VBA. I don't know how many of you are familiar or very familiar or not a little bit familiar with Excel VBA, but I'm going to start, just recording a macro. So one way to call VBA is to just go onto the developer menu at the top and you just call for VBA there. Okay, and that's going to bring this blank canvas. We have nothing created on VBA yet. And by the way, let me just close the other Excel file I have created before at the beginning test, not to have two on the VBA interface. So this is the Excel file we're working. And instead of going straight to VBA, I'm going to record a macro in Excel itself. So the way to do that is you go here again, developer, and you go record macro. And what this will do is it will turn into VBA code anything you do on the Excel. So let's just record anything, right? So let me just say, I'm going to name that macro test macro. Okay, that's it. And now it's recording. So everything that I do will be translated into code. So I'm just going to do something really simple. I'm going to enter a number 2 there. And on the cell right next to it, I'm going to enter a formula. And it's going to be that times 2. Very simple stuff. And I'm going to stop recording. That's all I did, right? I entered a 2 in that cell, and then I entered a formula, which multiplies that cell by 2. Now, I stopped recording. Now I want to see the code that was recorded. So you go onto the macros option there, and it tells you you have just one macro, the test macro that I just created, and you go edit. And that will bring, again, the VBA interface here. And you will see that the test macro was recorded. Those those are comments. You can delete them. This is the piece of code that was created when we did that. We entered a 2 there in that format. You can see if you haven't been in VBA ever, you can immediately notice that this is fairly intuitive to understand, right? So this is the code that we recorded where we entered a number 2 in that cell, range G3. In G3, we enter a number 2. And then in cell H3, we enter a formula which calls the preceding cell and then multiplies by 2. Now, let's say you want to edit the code. You can see here how intuitive this is. Instead of a number 2, let's enter number 10. And instead of multiplying by 2, let's multiply by 10. So if I run this code now with that play button, this is updated with a 10, and the formula is times 10. it calls the preceding cell times 10. So see how easily we created a piece of VBA code by recording macro in Excel. This is the best way to learn code, by the way. Just record yourself doing anything in Excel, and then you try to figure out what is it that the code is trying to tell you. Now, let me tell you another intuitive thing here. Remember that I told you you can name cells. So instead of referring to the cell G3 as G3, you can refer to that cell using the name. So let's say, for the sake of this silly example, let's say I want to use a year in which I was born, 1977. And here I'm going to calculate my age, and it's going to be current year, 23, minus that. So that's my age, right? So let me delete that, and I'm going to name this cell year, and I'm going to name this cell age, just for the sake of the example that I want to show you. So instead of referring to that cell, actually, I'm going to delete the whole thing for you to see how intuitive this is. So I want to refer to the cell year. So instead of using G3, just use the name, range year. And the beauty of this, then you can move this around, and it's going to retain that name. So instead of selecting the cell, I'm just going to enter directly a value, 19, let's say it's 1950. And I'm going to run that. Okay, but before running, let me enter the calculation in the next cell, which is age. Remember, we named that age there. And the calculation is going to be 2023 minus range year. As an example, you see how intuitive this immediately is? So let me run this now. And there you go. So it was 50 and 23 minus, and that's the number that ended up in the cell. So immediately you created a macro that you can run, and you can start populating your cells. The beauty of this, I was saying, you can just move these things around, and the cells will drag the name across. Okay. So you don't have to worry about what was the column or the row number. You just refer to the name. Now, another thing useful for you to know, this is another Excel little neat trick. You can run quickly, let's say a code. Let's run a 4 cycle from 1 to 10, and then you do next I. And I want to do is range. Let's use the same cell that I already named year. Okay. And I'm going to enter there the number I, where I is going to loop from 1 to 10. So what do you think this thing is going to do when I hit play? It's going to, let me just add there, offset I, comma 0. What does this mean? It tells you, go to the range year. That's the name of the cell that I want to start. And then go offset. Offset means move that, which is going to be a cycle number of rows, and that number of columns. So stand 0 offset in terms of columns. So therefore, stay in the same column, and then offset each time of the cycle I number of rows as you move down. So let's run that so you understand what it does. So it moved in each part of the cycle. It offset 1 row down, but no columns, 0 column offset. And then write in the cell the number of the variable I, which changes as you loop through the cycle. You can also do this by running with the F8 keyword one step at a time. So if I hit the F8 keyword, it moves 1 line. So that it wrote 1 in the first time of the cycle, it moved offset just 1. If you put the pointer over the I, it tells you what is the current value that that variable takes. So it took the value 1. Fi now in the second time, now it takes the number 2, and it's going to write here the 2 there. F8 again, now I takes the number 3 and writes again. So, and then I keep hitting the F8 keyword, and it finished the cycle, and it wrote the 10. So very briefly, I show you how you can actually turn anything you do in Excel into a piece of code by recording a macro, and then you can very intuitively understand what the piece of code is actually telling you in each line, and you can start playing around with editing this code to understand how you can translate complex operations into an Excel sheet. So I really encourage you to learn VBA if you haven't already done so. This is the best way to learn. Just record yourself doing and try to figure out what the code is telling you. And then you can multiply your skills by, multiplying your capabilities many-fold instead of doing manual stuff in Excel. Okay, so let's move along. So what I want to do now is to actually repeat the calculation of the Z factor, but instead of doing it on Excel itself, I want to do it via code. Okay, now again, I'm just going to be using the formulas as expressed in that Whitson website. So if I bring the website again, and what I want to do now is to write a piece of code within VBA. And the first thing that I want to do is to calculate the pseudo-critical pressure using that formula there. 756.8 minus 131 times gamma. Gamma is the variable that I'm now passing as parameter of that function, and times minus 3.6 times gamma square, right? So I've done a very simple piece of code where all I've done is I brought to the VBA the very same formula that I used here, pseudo pressure. That's the very same formula, but I'm writing that formula inside VBA. Now, the beauty of this thing is now this is a public function. What that means is now you have an available function for you to use anywhere in Excel or anywhere in any other workbook. So you can call this function as you would with any other function. So let's say you go insert function, and then you select here user defined functions, and that function is available for you to use like any other Excel function, right? So select that. That's the name of the function, PSC, and you hit OK. Now it's going to ask for that one parameter that it needs, which is the gamma, or specific gravity, that is used within the formula. And now, because it's an Excel function now, you can actually do not need to enter a number. You can actually refer to a cell. So I'm going to click on that cell, and it's going to bring that cell into the formula, and there you go. I have calculated now via a VBA function the pseudo-critical pressure. Now I can do the same with any other one. So let's bring now the formula for TSC, sorry, the pseudo-critical temperature. That's the formula that you see on the Whitson website, 169.2, 349.74. That's the formula. It's exactly the same formula that I had used before here. That's the formula, right? Now I'm creating a public function using VBA. Okay, so now, same as before, I'm going to call a user-defined function. Now it's the temperature, and that is going to, again, ask for the specific gravity. So you can call that cell with specific gravity, and okay. So you see it's the same number. Now I've calculated it using a user-defined function. Now the beauty of this, as I said before, is now you have an Excel function available to use anywhere in Excel, even in other workbooks. So let me open a new Excel workbook for you to see what I mean. So in here, if I have another blank workbook and you need to calculate stuff, you can actually find this formula here as well. So you go insert function and you go user defined, and now it tells you, but it tells you that it comes from a different workbook, but still available. So PSC, the gamma, you can now refer to a value in this workbook. You don't need to go to the other workbook. Let's say the gamma is there. I didn't enter it, so it's going to throw. So 0.5. You see it updates. It refers to that cell is calling that gamma, or GG. Is the one that I use in the formula, and it updates. Okay. So very handy to build public functions. So you have the ability to call on those functions anywhere in Excel, in any workbook. Okay, so let's continue now, and let's bring now the public function for the set compressibility factor. Okay, that's it. So I brought the entire formula. You need to trust me that I brought the exact same formulas that are in the website that we've already implemented in Excel. These are the formulas that we have, and this is where the iteration happens inside of the code. So we don't need to invoke goal-seek or do any iteration in Excel itself. All of that happens inside of the code. So you can explore this in your own time, but the idea is exactly the same. You start with a value, you calculate the f's and the derivatives, and then this asks within the code, is that low enough? If yes, exit. If no, go and iterate, changing that value by a different, by splitting that with the Newton-Raphson methodology. Okay, so this is typical methodology to iterate on that optimization little routine there. And once we have that, we have the function we need to calculate the set factor. So we go to set, as I did before, PC and TC, and we got the same numbers. Now let's go here and let's calculate the set factor invoking that set function. And that's going to need the pressure. So the pressure is going to be that value. The temperature is going to be that value. And the specific gravity is going to be that value. And okay, boom, there we go. That's the set factor calculated with our set function rather than iterating within Excel. Okay, great. So what's next? What we want to do next is to turn this into a friendly user interface. But before doing that, let me just briefly, I know we're running out of time already, but one thing that is very handy, obviously, when you have this as a function, and you can imagine yourself having a list of pressure values. Let's say, let's create a list of pressure values all the way from 5,000 to 500. And here I'm going to calculate the set factor, and I can use the formula that we just created. Okay, so that is going to be calling for pressure. And instead of calling the one that I have there, I'm going to call that cell. Temperature is going to be that one. I'm going to absolute it with the F4 keyword. So as I move down, that doesn't change. And the specific gravity again, it's going to be gamma. That doesn't change because it retains the name. Okay, so that's the set factor. And if you copy that down, you can see there it's calling that gamma and that temperature and that pressure. Okay, gamma, temperature, and pressure. Okay, so very quickly, we created ourselves already a set function. And we can chart this and see how the set varies with pressure very quickly using the formula we just created that leverages the Joule-Harborough correlation. Now, the next bit is let's turn this into a visually appealing interface. So the first thing we want to do is to go back to the VBA interface. And now what we want to do, so let me close that workbook, book 3 we created, just to delete that from there. So this is very clean now. And let's go back to Visual Basic. That's our workbook. And what we want to do now is to create a form. Okay, so we're going to go there, insert, and go user form. You have this toolbox here, and you have this property panel here. So the first thing we want to do is you click on the element and you want to give that a name. So let's say that's called a PVT. How can that's the name of our form element. Okay, so you need to give it a name that is going to mean something that is logical to you when you first look at it. So FRM for form, and then let's say there's a gas PVT. And the caption is what actually shows on the form itself. So the caption user form 1 is what shows there. So this is the internal name of the element. This is what you want that to display. So let's say PVT calculator or whatever, right? And we know we need 3 elements. We need a gamma. So that's going to be caption of that element label 1, gas specific gravity, enter, that's it. And now we're going to create another one for the temperature. So just click on that and just drag on this form element. So we're going to label that as pressure. Okay, enter, that's pressure. And again, click on the element toolbox, that text element, and this is going to be temperature. Temperature, enter. That's it. Okay, and you can drag this around to make it more visually appealing, so you can play around with this in your own time. So for now, let's do just that. And then what we want to do is to enter a text box. So we're going to call this text box. So TXT for text, GG for gamma. Then we're going to create another one. So remember that text box, we're going to drag that there. I'm going to name that TXT. This is going to be pressure. Enter. And then again, we're going to text box there. And this is going to be TXT or text element and temperature. Okay. That's it. So we have the three inputs, and now here we want to have the calculations. That's going to be a command button. Okay. And this is what's going to run the calculation. So the caption is going to be Z equals, and here's where we want to drop the value of the calculation itself. Okay. So we bring again the text box, and we're going to name that text TXT and set, because that's the value we want to bring. So what we do next is when you double click on any of these elements, it brings a piece of underlying code that is going to run when you hit that element. Okay, so what we want to do here is to now allocate values to those elements we just created in the form. So let me just, for the sake of time, copy this that I already had created before. Let me make it more understandable to you. Okay, so that's the sub, or the subroutine, or the procedure that's going to be run when we hit that command button. Remember, that's the command. When we hit that, it's going to run that code, and that code is going to actually, remember the naming we use in Excel. So the range gamma, that's that cell there, that cell is range gamma, is going to be allocated the value, which is the TXT GG element. So that's how we name that element. Remember, TXT GG. So what we're saying here is that cell is going to acquire that value, which is the value of that element there. And same with the other ones. Pressure, range C6, sorry, is that one, is going to take the temperature value, and range pressure, which is that cell, is going to take that value. And then the other way around, we're going to bring to the form element the value from the sheet now. And the sheet is going to be range Z calc, which is the one we're calculating here. So we need to name that Z calc, and that is the value that is going to be brought to the form element. So if we run this form now, let's have a look if this works. So we run the form, and it's going to bring this form here, and we're going to enter value. So let's say 0.6, pressure is going to be, let's say 4,000, and temperature, let's say, is 150. If we hit Z, it's and the sub in function, yeah, so that's a problem in the code. I forgot to delete that line. So let's run this form again, and specific gravity point, let's say 0.5 for the sake of the example, 4,500, 0.50, and Z. And Z is bringing 0.98. So this is what happens. In the sheet, we enter 0.5 and 4,500 and 150, and it was brought back to the form, the value from the sheet. So if I close that and check that those were the numbers there, that's exactly 0.5, 4,500, and 150. Let's do it again. Let me drag this to the top so we see everything next to each other. So those are the values that I'm playing around in the form, right? That's it. So let me just highlight that. Just very briefly. With that, just so you understand side to side, when I run the form, I'm going to run the form again. So here I am, run the form. And what I want to do now, specific gravity is going to be 0.65, pressure is going to be 2,500, and temperature is going to be 250. Let's run Z. There we go. So 65 was brought to the sheet from the form, 2500 from the form, temperature 250 from the form, and now Z was calculated here by the function we created, and the resulting value was brought to the form. So if you are the user, this is all you see, right? Now, I don't think I will have time to go through the entire process of creating the entire application, but let me just see if I can manage in the remaining 7 minutes very briefly. So the way to do this is now I'm going to create a little routine that at the end here in the modules where we create the code, I'm going to create a little run form routine that is going to open that form PVT every time we run that hit. So for example, if I run that routine now with the play, it's going to bring the form. Okay, it did run the form. This is the same as running the form there, but now doing it from within a routine. And you also can do is to bring that little piece of code to this workbook page here. So that means whenever I open this file, open the form immediately. This is what that instruction means. Just to test that, let me just close this and save it. Okay, save it. And now I'm going to bring where I have saved that file. So I'm going to open it. And immediately, as I open that file, it's going to trigger that form. So the form is going to open immediately. So I'm nearly there. I'm nearly where I want it to be. All I need to do now is to hide the Excel altogether. All I want for the user is to see the form. And the way to do that is with a little routine. So let me just close that. With a little routine, which you can create as a Visual Basic script. Okay. And I won't have time to do it from scratch. So let me just show you what the routine looks like. This is simple. This is a simple script that you run in Notepad. It's just a little piece of code. All it does, it says, this is the code. You define a variable, my app, which is going to refer to the Excel application. And I'm going to give the instruction to not be visible. You do that, but making that visible property false. Okay, so I'm saying do not show it when you run Excel. That's what I'm saying. And in here, you just bring the path to the Excel file you just created. Okay, and then a little bit of an instruction to not warn you when you close the file. So it closes immediately. So once you have that, you can actually drag these to your desktop, and you can change the icon to something more appealing to you. So if you run that, what it's going to do is to open that Excel application, bring the form, and exactly as we saw, unfortunately, I'm not going to have time, so I'm running 4 minutes late, but you see that up there is that Visual Basic script, which you create in Notepad. You just save that with the extension. That's the only key, right? You just save that. Let me close that file. That's why I couldn't do it. So you bring that to your desktop and you just change the icon to something else. But the point I was making is when you bring that open with Notepad, this is a simple script you create in Notepad. And then when you save this, you just give Visual Basic script extension. So script 2, you just explicitly specify Visual Basic script. That's it. And that'll turn that Notepad file into a script. You see the icon? That's a script icon. And then you can double click on it and run it. And all I was telling you just now is you drag that to your desktop, okay? Or as a shortcut to your desktop. So you can right click on it and go to properties. And in properties, you can change the icon to something, anything. You can bring your own icon, right? So there you have, an icon on your desktop, and that icon is going to run the script. And that script is going to open the form. It's going to hide the Excel application, and you're going to end up with this. Okay, so there you go. An Excel-based application for you to calculate anything you want. I did it with the set compressibility factor as an example. Obviously, you can actually extrapolate from here and build anything you want using Excel, especially because all of you are already very used to working with Excel databases anyway. So it only makes sense that you have the capability of creating applications within Excel without having to go to third-party software all of the time. Many times you don't want to get out of Excel and you want to run PVT calculations inside of it or anything else, relative permeabilities, pressure profiles, anything you can think of. So I am sorry I had to rush through this at the very end. We ran out of time, but I'm gonna open the mic to Esan for closing remarks. Sorry for the rush, guys.
Thank you so much, Alan, for this interesting webinar. Very professional, actually, and also very interesting skills using Visual Basic and Excel. So very interesting, and we are looking for more, actually. Everyone, please take a few minutes to fill in the feedback form. I will send it in the chat now. So please fill in the feedback forms. This will help us to improve and provide you with your needs in the upcoming webinars. I will give you 2 minutes to fill in the form, and then we will head to the Q&A part. So please take the time to share your questions and your thoughts with us in the chat area, and we will discuss this with So we have actually received 2 questions. The first one from Dimitri is asking, what about using some software like PVTX or PVTI programs for these tasks? So, Alan, do you have comment on this?
Yeah, of course you can use any PVT software to run these calculations. The whole point is precisely to be able to, for you to leverage Excel capabilities to build your own stuff. I use a PVT calculation as an example, but the intent of this presentation or this webinar was for me to show you Excel capabilities that some people haven't had exposure to. So the ability to build your own stuff within Excel, leveraging VBA for no much extra effort. Some people are not into coding. Some people run away from VBA, and I wanted to show you that you don't have to. It could be very intuitive, and you can leverage the power of VBA to run calculations inside of Excel. As far as PVT itself, of course, you can use any other PVT package, but many times you don't want to get out of PVT of Excel. It just takes, it adds friction to the whole process. You may have already a database built in Excel, and you want to quickly calculate stuff off of that database without having to export data set, importing somewhere else, calculate it and bringing the results back, all of that. So it's also useful to remove all of that friction inside of Excel. But it's up to you. The idea, again, was to show you the capabilities that sometimes people are not aware of, the immense power that you do have within Excel itself, leveraging VBA and running many times just visually appealing user forms like these ones for any other non-tech people to enter their inputs and get the results they need without having to go into immense formulas and calculations and tables and so on and so forth. That's the idea.
Yeah, totally agree with you, especially that we all have Excel on our PC. We don't all have access to some software like PVTX or PVTI. So it will be a good mean to have this application using your Excel.
Yeah,
So,
many times,
yes,
just to add on to that one final remark, many times, I'm an engineer and most of you will be engineer here, I would presume, but many times you have geologists coming and, exploration geologists who run in-place calculations, and they always come to you and they ask you, hey, what's the expansion factor or the VG? That's all they need, right? They don't want to go through the hassle of having to run calculations themselves. But with this thing, you can give them a very simple form where all they need is to put the pressure and temperature and gas gravity, or you give them the gas gravity, and they can play around with ranges for it themselves. So without you having to be the one bottlenecking their progress.
yes, yes. So we have also a question from Dimas. He's asking, can we use these PVT calculations for creating phase envelopes? Have you tried this before?
Well, once again, the idea here is to leverage Excel and VBA to build anything you want, man. If you have all the procedure well described and the methodology and the formulas to, in increments, build all the parameters you need, of course you can. Now, it's a little bit more challenging. Phase behavior is a complex stuff, and you might want to resort, in this case, I would resort to specialized software. But in principle, the idea here is, again, to leverage VBA to build inside of Excel anything you want. It doesn't need to belong to the realm of PVT and equation of state. It could be anything else. Think of rail perms, think of pressure profile, think of well testing, think of anything, right? The idea is to turn sometimes, very clunky and not very user-friendly Excel tables and formulas and worksheets and stuff into something which is more user-friendly for a broader range of users. And also for you to realize that you have some, very powerful capability inside of Visual Basic, and many people are not aware of that. And sometimes it takes just a little play around with it. You can record yourself doing a couple of things with those record macro function, and then you can figure it out yourself how, playing around with parameters inside the code changes what you see on the Excel sheets directly. So it's more of an enticing you to play around with what you have in terms of Excel plus VBA capability, rather than an absolute path to any individual solution.
Yes, totally agree. So guys, I'd like to remind you again with feedback link. I will share it again in the chat area. This is very important for us. Also would like to highlight and mention that this webinar is live streaming on YouTube channel, our YouTube channel. So I really encourage you all to go to watch it several times and practice yourself using your Excel and BC to manage these Excels.
The question from Ahmed is a good one there. Can you automate the set versus pressure in a table or chart? Yes, you can. You can bring the same as I did. I brought back to the form just the Z value to that field. You can bring to the form a chart. You can bring a table. You can send to a table. I mean, you can do many things out of the form interface without having to interact with Excel itself. Yes. Unfortunately, there wasn't time to do all of that, but yes, you can.
Yes, thanks for answering this. So everyone, thanks for joining us again. Hope to see you all in the next webinar.
One final closing remark, guys, from me is, once again, if you go to the website, the CrowdHill website, and you head to the digital store, I have 2 products at the bottom here that you might want to have a play around. These are free for you to download. One is using Excel as a preprocessor to build an entire Eclipse 100 data deck, right? So you build everything from within Excel, and you have your simulation.data file ready for simulation. And the other one is to use Excel and Power Query to leverage the capabilities you have. This is not VBA, this is Excel and Power Query. I'm not sure how many of you are familiar, but I really encourage you to have a play with these 2 tools, which again leverage the powerful capabilities of Excel without having to resort to fancy third-party software. So go to the digital store, download this stuff for free, and have a play. And I'd be keen to hear your feedback of this session and design down the track additional webinar sessions on topics that you are most interested about.
Thanks, Alan. I also shared the link to this page on the chat area now. So you can type crowdfield.net/store. You'll find these projects by Alan. Thanks, Alan, for sharing this. This is very professional, actually.
Yeah, absolutely. And the idea for the whole website is actually to invite any of you guys to bring your own products to market. So these are 2 products of mine that I left there as examples, but imagine products of your own creation. We can bring them to the digital store, and this can be sold in the open market for a fee to anywhere in the world. That's the whole purpose of this website. So have a look through the website to understand what the value proposition is, and get in touch with me if you want to have a chat further. And yes, I'm keen to continue this webinar series with any other topic that is interesting to the public. So let us know.
Yes, sure. And thanks for this initiation, actually. So finally, thanks, Alan. Thanks everyone for joining us today. Thanks.
My
for
pleasure.
being on. Yeah,
thank you for the invitation, and yeah, thank you guys. Appreciate your presence.
So everyone, have a nice day. Bye.